Welcome to aminacademy.com. In electrical engineering, let us discuss about cylindrical capacitors with compound dielectric. Look at this figure, that cylindrical capacitor cross section having different dielectric medium. Let R1 radius of the core. R2 radius of inner dielectric. Inner dielectric epsilon R1 and R3 radius of outer dielectric. Epsilon R2. Obviously, we know that previously discussed two capacitors joined in series. Now C1 equal 0.024 epsilon R1 over log 10 R2 by R1. We discussed the previous videos. This is C1 and microfarad per kilometer length, and C2 equal 0.024 over log base 10 R3 by R2, same microfarad per kilometer. Total capacitance here, total capacitance is Z. Here both are in series. We have C1, C2, because two capacitors C1 and C2 consider as a series. Now then Q charge is in series capacitor charge is C1 V1 is equal C2 V2. Charge is equal in every capacitors. Therefore, from this we can write V1 V2 over V1 equal C1 by C2, which gives epsilon R1 log base 10 R3 by R1 over epsilon R2 log base 10 R2 by R1. That is, you are substituting the value of C1 and C2. From this relation, V2 and V1 can be found. Therefore, from this relation, you can find V1 and V2. Now, let G max maximum gradient in inner capacitor is equal V1 over 2.3 R1 log 10 R2 by R1. Similarly, Gmax for outer Gmax for outer is V2 over 2.3 or 2 log base 10 R3 by R2. Now ratio of Gmax Gmax1 over Gmax2. Gmax2, that is Gmax1 by G, that is inner to outer, is equal the ratios V1 by 2.3 R1 log base 10 R2 by R1 division V2 over 2.3 R2 log base 10 R3 by R1. Now by simplification we have Gmax1 by Gmax2 equal that is equal V1 R2 by V1 by R2, then V2 by R1 into log base 10 R3 by R2 over log base 10 R2 by R1, which is further equal C2 R2 by C1 R1 into log base 10 R3 by R1 by log base 10 R2 by R1. Since we have V1 by V2 equal to C2 by C1, the relation. From this relation we got here. Now putting the values of C1 and C2 we have the values of C1 and C2, and this relation will get Gmax 1 by Gmax 2 equal 0.024 over epsilon R2 over 0.024 epsilon R1 first we will find the value of, then log 10 R2 by R1 into log 10 R3 by R2 over the division becomes multiplication reciprocal 0.024 E R1 by cancelling the constant terms, equal terms, that is which is equal R2 by R1 into log base 10 R2 by R1 over log base 10 R2 by R1. So Then therefore from here we will get from this we can get G max 1 by G max 2 equal relation sigma R2 into R2 over sigma R1 into R1. This is a simple relation we got, simplified relation. That is, hence the voltage gradient is here, voltage gradient is inversely proportional to, therefore GR1, GR2, G max 1, G max 2, voltage gradient is inversely proportional, to the permittivity and inner radius of the insulating material. Now we got the relation G max 1 over G max 2 equal to epsilon R2 into epsilon R2 into R2 over epsilon R1 into R1. Now let us do an example problem to understand this concept clear. A single core lead sheath cable with a conductor diameter 2 cm is designed to withstand 60 kilowatt. The dielectric consists of two layers A and B having relative permittivities of 3.5, that is epsilon R1 is 3.5, epsilon R2 is 3 respectively. The corresponding maximum permissible electrostatic stresses are 72 and 60 kilovolt per centimeter respectively. Find the thickness of two layers. Here we have the relation G max 1 by G max 2 is equal epsilon R2 into R2 over epsilon R1 into R1. That is equal, or we can say from this V G max 1, G max 2, or the relation is 72 volt and 72 kilovolt per centimeter, 72 by 60 equal 3 R2 by 3.5 R1. R1 is here, this is for the by 3.5 and therefore from here we can write the relation, find the thickness of two layers. Therefore R2 by R1, is 72 by 60 into 3.5 over 3. We calculate this. Here 72 multiplied 3.5 divide 16 to 3 equal to 1.4. Relation, the ratio of R2 by R1 is 1.4. Now further, we can find that V1 is RMS root mean square values of the voltage across the first dielectric, that is V1 equal root mean V1 is RMS root mean square values of voltage V1. Voltage is voltage across first dielectric. Now we can find that is 72 given is V1 into root 2 times, because RMS values by 2.3 into or 1 kilometer into log less than R2 by R1 is 1.4. By calculation we get V1 equal 17.1 kilowatt. V1 is 17.1 kilometer. Then from that V2 equal 60 minus, because the voltage given withstands 60 kilovolt. That dielectric to dielectric withstands 60 kilovolt. So it equals 60 minus 17.1, which gives 48.9 kilovolt per kilometer, because we are using 1 here. Therefore, now G max 2. G max 2 is V2 root 2 over 2.3 R2 log base 10 R3 by R2, R which is equal 60 equal 48 48.9 48.9 over 2.3 into 1.4 log base 10 R3 minus R1, R3 over R1. From this we can get the value of log base 10 R3 by R2. That means from the cross multiplying this 2.3 go here, and 4.8 48.9 will come, and 1.4 also up. So we have the relation log of R3 by R2 is 0.2531. From this log 10 we have, from that taking anti-log and finding the value of R3 by R2 equal gives approximately 1.79. 1.79, the ratio 1.79. 79. Then from this relation we can get R3 because already we have R2 and R3 is 2.5 because we can get it here. The R3 is from this calculation 2.5 centimeters. Therefore, thickness of first dielectric. Thickness of first dielectric is 1.4 minus 1.0 equal 0.4 centimeter, and for second layer we have 2.5 minus 1.4 because it's next to next, that is 1.1 centimeter. So we are using here better to write small radiuses R1, R2 and R3. We have done. Please subscribe our YouTube channel.